There are moments in science when a discovery doesn't simply expand our understanding of the universe, it disrupts it. And that's exactly what is happening now. Over the last few years, astronomers have detected a class of exoplanets that defy every model, every simulation, and every physical law we thought governed the formation of worlds. These planets should not exist. Their orbits are unstable, their temperature is impossible, their densities contradictory, and their atmospheres behave as if they come from an entirely different set of cosmic rules. When NASA first identified some of these worlds, the reaction wasn't excitement, it was confusion. Because some exoplanets orbit so close to their stars that the star's gravity should tear them apart in a cosmic heartbeat, yet they remain intact. Others orbit so far out that they should be frozen solid, but they glow with unexpected warmth. And some, astonishingly, seem to have the wrong mass entirely, as if their internal structure is made of something we've never seen. One planet, for example, is so low in density that it's been described as cotton candy-like, a gas giant so puffy that its atmosphere shouldn't be able to remain gravitationally bound. Another, far stranger, is so dense that astronomers believe it may be the exposed core of a dead star masquerading as a planet. And then there are the orbital anomalies. Several planets loop around their stars on paths so elliptical, so stretched and distorted, that computer models crash trying to simulate their stability. These orbits should decay. They should collapse. They should fling the planets into space or pull them into the star within a few thousand years, a blink in cosmic time. And yet they persist, as if some unseen force is either stabilizing them or has recently placed them into these strange patterns. But the discovery that truly alarmed scientists wasn't about the orbits or the atmospheres. It was about energy. A handful of exoplanets are emitting far more heat than they receive from their stars, so much so that natural explanations barely hold together. Tidal heating, radioactive decay, even residual formation heat shouldn't be enough. Something else is happening, and no model fully explains it. For the first time, astronomers are admitting the possibility that the universe might be hiding entire categories of planets we were never prepared to find. Take, for instance, the superheated giants known as ultra-hot Jupiters. These worlds orbit so close to their stars that their atmospheres are hotter than the surfaces of some small stars. Materials like iron and silicates evaporate, forming metallic clouds that rain molten droplets. Winds howl at thousands of kilometers per hour, carrying vaporized rock from the day side to the night side. On paper, these worlds should shred apart. Their atmosphere should blow away in days, not billions of years. Their magnetic fields shouldn't survive. There should be nothing left to observe. But Webb has revealed something astonishing. Some of these ultra-hot planets have temperature distributions so uniform that the only explanation is an atmospheric circulation more powerful than anything ever observed. Entire hemispheres that should be blistering hot are remarkably balanced, as if some planetary mechanism is redistributing heat with extreme efficiency. And then at the opposite end of the spectrum, we have the rogue worlds, planets drifting freely through space without stars. These planets are cold, dark, and theoretically incapable of maintaining anything but a frozen crust. Yet observations show some of them glowing faintly in infrared. They're warm, not from starlight, but from something internal. Perhaps radioactive decay in quantities far above predictions. Perhaps massive molten cores insulated by thick layers of hydrogen. Or perhaps something no one has considered yet. Even more concerning is the so-called impossible Neptunes. These are mid-sized planets with atmospheres far thinner than their gravity should permit. It's as if they lost most of their original mass but survived the process. Some scientists believe this is evidence of extreme atmospheric stripping from violent stellar activity. Others propose a catastrophic past event, a collision, a near miss with another planet, or even an encounter with a passing star. But the most shocking category of all is the hybrid planets, worlds that show signs of both rocky and gaseous composition in ways that should not coexist. Their mass ratios make no sense, their atmospheres don't match their predicted cores, and some even have spectral signatures suggesting materials that shouldn't survive the temperatures on the surface. These findings have led to a quiet but growing suspicion among researchers that planet formation in our universe is far more chaotic, far more violent, and far more diverse than the neat diagrams in textbooks suggest. Something is happening out there, something unpredictable, something strange, and something we still don't fully understand.
But the greatest concerns come from a completely different category, planets that seem almost purposefully misleading. These are the worlds that look ordinary on first inspection, Earth-sized, rocky, sitting neatly inside their habitable zones, yet hide inconsistencies that scientists are struggling to explain. For example, several Earth-like planets orbiting red dwarf stars show atmospheric signatures that suggest far more energy than their stars provide. Their night sides, which should be icy and dark, emit surprising warmth. Their day-side temperatures fluctuate in ways no model predicts. The simplest explanation is tidal heating, but the numbers don't match. The heating is too strong, too widespread, too stable. Some researchers suspect these planets may have internal oceans, kept warm by gravitational forces from neighboring planets. Others wonder if dense, greenhouse-heavy atmospheres are trapping more heat than expected. But there is a more unsettling hypothesis, that some of these worlds experienced catastrophic formation histories, leaving behind molten interiors that cool extremely slowly. In such cases, what looks like a calm, Earth-like planet on the surface could be a volcanic nightmare beneath the crust. Another anomaly lies with planets that should have thick atmospheres but don't. There are rocky worlds with surface gravity strong enough to hold gases easily, yet their atmospheres appear to be stripped down to almost nothing. If stellar winds are responsible, they would need to be far stronger than the star's characteristics suggest. Something isn't adding up. And then there are planets with orbital tilts so extreme they defy expectations. Worlds spinning almost sideways, worlds rotating backward, worlds with seasons so violent they should destabilize the climate entirely. These planets shouldn't be stable, yet their climates appear surprisingly consistent. Webb's observations have also uncovered exoplanets with chemical imbalances that raise eyebrows. Oxygen without methane, methane without carbon dioxide, strange ratios of carbon monoxide that suggest atmospheric processes we've never seen. Not evidence of life, but evidence of something acting on these atmospheres in ways nature hasn't shown us before. One planet even shows hints of silica particles high in the atmosphere, a sign of volcanic plumes reaching altitudes previously thought impossible. Each new discovery chips away at the comforting idea that planets form in predictable ways. Instead, the universe seems to prefer chaos, extremes, and anomalies that challenge our most fundamental assumptions.
So why are scientists truly worried? Not because these planets threaten us directly, but because their existence exposes enormous gaps in our understanding of physics. If these worlds defy the rules, then the rules may not be complete. Our models of gravity, planetary cooling, atmospheric chemistry, and star-planet interactions might only describe a small fraction of what's actually possible. And if we're missing something fundamental about how planets work, then we're likely missing something crucial about how life arises and where it might exist. The discovery of impossible exoplanets forces us to confront a humbling truth. Earth may not be the standard of habitability. It may not even be typical. For every familiar world, there may be thousands that evolved under conditions we've never imagined. Life could thrive in permanent twilight zones, beneath kilometers of ice, around rogue planets warmed only by internal heat, or inside atmospheres locked in chaotic chemical cycles. And if life can survive there, then our search strategies must change entirely. Future telescopes will not look only for water or Earth-like temperatures, they will search for energy flows, atmospheric anomalies, heat signatures, and chemical imbalances that hint at unexpected biology. Missions like the Habitable Worlds Observatory will examine exoplanets with unprecedented detail, scanning for spectral fingerprints of life that no human eye could detect. But beyond the scientific implications, these discoveries spark a deeper, more philosophical concern. If planets can form in impossible ways, orbit in impossible paths, and survive impossible conditions, what else in the universe might operate outside the boundaries we assume? Could there be forms of life, forms of matter, or forms of planetary evolution that we have never theorized? Could our understanding of star systems be based on a tiny, unrepresentative sample, our own? The universe is speaking through these strange planets, and the message is clear. We have only scratched the surface of what is real. Somewhere out there are worlds stranger than fiction, worlds that rewrite the laws of nature, and worlds that remind us that our cosmic knowledge is still in its infancy. The question is no longer whether these impossible planets exist. We know they do. The question is whether we can understand them before the next discovery shatters our expectations again.